So standard physics tells us, that reality at its most fundamental level is just this blur of probability waves and completely abstract math.
Right. It's very detached from anything physical.
Yeah, and if you're listening to this, you've probably heard the greatest hits of quantum mechanics, like how a particle can somehow exist in two places at once, right?
Superposition, yeah.
Exactly. And the mere act of a human being looking at that particle somehow magically forces it to choose a single path, which is wild.
It really is. It defies common sense.
Right. And we're basically taught to just accept this unexplainable weirdness, that the universe is inherently spooky and built on an empty mathematical void.
Well, yeah, but what if those abstract mysteries aren't actually abstract at all?
Yes. Because what if everything we call, quantum weirdness is actually the result of highly tangible, invisible fluid dynamics, like playing out all around you right now?
We're looking at a complete paradigm shift here, truly.
Welcome to today's deep dive. I'm so excited for this one.
It's going to be a lot to unpack, but it's fascinating.
It really is. So our mission today is to explore a revolutionary stack of theoretical physics papers. Specifically, we're focusing on texts like the electrodynamic universe and the BEC permeability proof.
Along with a lot of the dense, really paradigm-shattering supplemental research surrounding them.
Right. And we should make it clear to the listener, we are just imparting the ideas from these sources. But if these papers are right, this doesn't just solve the infamous double-slit experiment in a laboratory.
No, it goes way beyond that. The thread we are pulling today scales all the way up from a single photon to literally how we build spacecraft.
It's unbelievable. So here is the roadmap for you guys listening. We are going to trace that exact through line.
Starting with redefining quantum observation as fluid mechanics.
Yep. And then we're going to talk about physically cutting quantum entanglement with a laser, like literal quantum scissors.
Which sounds like sci-fi, but the math is there.
And ultimately, we're using these subatomic revelations to explore engineering propellantless warp drives and G-force mitigation for fighter pilots. So, okay, let's unpack this.
Well, the foundation of this entire framework, it requires a massive pivot in how we understand the vacuum of space.
Right, because standard quantum field theory just treats the vacuum as a backdrop, like an empty stage.
Exactly. For the last century, it's largely been a mathematical void. Sure, standard theory acknowledges virtual particles, popping in and out of existence.
Phone.
Right, but it's still treated as a fundamentally empty void where probability waves just propagate.
But these papers say something completely different.
Yeah, they posit that the vacuum of space is a highly tensioned physical medium. Specifically, they define it as a Higgs QCD superfluid.
Okay, a superfluid, meaning like a fluid with zero viscosity. It flows without any friction whatsoever.
Precisely. The papers detail it as a Bose-Einstein condensate, or a BEC, and it's comprised of virtual bosons.
Let's ground that concept for a second, because a Bose-Einstein condensate is a state of matter we usually only see in very extreme lab conditions, right?
Yeah. Usually when we cool a gas of bosons down to just a fraction of a degree above absolute zero.
Right, and at that temperature, the particles basically lose their individual identities, like they stop being independent.
They clump together into a single macroscopic quantum state. They behave as one unified wave.
So if I'm understanding this framework argues that the entire background of the universe, like the space sitting right between you and the device you're listening on, is actually this hyper-cooled, frictionless ocean.
An ocean of virtual particles acting as a single coherent fluid.
Yes. That is just, it's hard to wrap your head around. The vast voids between galaxies aren't empty. They're full of fluid.
And that frictionless ocean is the canvas for every interaction of the universe. Everything happens within it.
Okay, so we need to keep that physical medium in mind because it completely rewrites standard textbooks, like specifically Chapter 15 of standard quantum texts regarding the observer effect.
And the double-slit experiment. That's the classic example.
Right, the double-slit mystery. Let's recap that real quick. You fire single particles, like electrons, at a barrier with two slits.
And if you don't measure which slit the electron goes through, it acts like a wave.
Exactly. It passes through both slits, interferes with itself, and creates this wave-like interference pattern on the back wall.
But the moment you put a detector next to the slits to see which one it went through,
the pattern completely collapses. It suddenly acts like a little bullet going through only one slit.
Which is the core of the Copenhagen interpretation.
Right. Standard physics says the particle exists as a superposition of all possible states until an observer looks at it.
basically forcing the mathematical probability wave to collapse into a physical reality just by looking.
Which honestly has always sounded a bit like magic to me. It implies that human consciousness, or just the passive act of measurement, dictates physical reality.
It strips away mechanical causality. It makes the universe subjective.
Exactly. But the papers we are looking at today, they throw that mysticism out entirely.
Yes, they offer a deterministic hydrodynamic solution. They call it macroscopic transceiver coupling.
Macroscopic transceiver coupling. I love how this grounds the act of observation into cold, hard thermodynamics.
It's very mechanical, because in standard physics, they treat a detector like a passive, objective eye.
Like it just watches without touching anything. But physically, there is no such thing as passive observation.
Right. To observe a particle, your detector physically has to absorb some amount of energy from it.
Like a camera has to absorb photons to take a picture. An electron detector absorbs kinetic or electromagnetic energy to actually register a hit.
And this absorption of energy, according to the text, is a thermodynamic event. They define it as a topological facelift.
Okay, topological facelift. Let's look at the mechanics of that.
Well, when you turn your detector on, it doesn't just sit there passively.
Right.
By drawing in energy to make a measurement, the detector creates a highly localized pressure drop in the surrounding medium.
It's an energy sink. Think of the detector not as an eye, but as an active vacuum cleaner submerged in an ocean.
That's a great analogy.
When you turn the vacuum cleaner on, it starts pulling water toward it, right? It changes the currents.
Exactly. And the Ginzburg-Landau free energy equations mathematically describe this exact process.
Oh, right, because a superfluid is contiguous and incompressible.
Yes, meaning it constantly seeks to minimize its free energy globally. It wants equilibrium.
So when your detector absorbs energy, it's actually lowering the local Ginzburg-Landau free energy of the vacuum right at the detector's physical location.
And this localized pressure drop instantly creates a continuous directional phase gradient in the local superfluid vacuum.
A phase gradient, the mathematical representation for that is del theta, right? The little upside-down triangle and the theta symbol.
That's the one, nabla theta. And this gradient is established in the physical space between the source of the particle and the detector.
Okay, this is the crucial paradigm shift. This is where it blew my mind. It's about the timing, right?
Yes, this gradient, this literal physical tension pulling through the vacuum fluid, it is created the exact moment the detector is turned on.
Which is before the source even fires the particle.
Exactly, before the particle is emitted. The text calls this preconditioning the vacuum phase.
Preconditioning. So the environment is basically rigged before the race even begins. The detector tilted the table.
That's exactly what's happening.
Right.
So when the particle is finally emitted from the source,
It doesn't fly out into an empty void as some magical probability wave.
no. The papers describe the particle momentarily dissolving into what they call an unspooled, propagating wave of polarized vacuum energy.
Because it's a wave propagating through a fluid, it deterministically navigates that pre-existing gradient.
Right. It flows down the path of the least physical resistance. It's just riding the hydrodynamic currents directly toward that pressure sink.
Wow. So the particle's trajectory appears predetermined to us, not because of some mystical quantum knowledge of the future, but because the macroscopic environment, like the detector itself, preconditioned the hydrodynamic topology of the vacuum.
Observation is literally just a detector drinking from a superfluid.
That entirely demystifies wave function collapse. Like, there is no collapse.
There's only fluid mechanics.
It's so clean. But, I have to push back here, though. Let's really stress test this fluid model
Sure. Where are we testing it?
against Wheeler's delayed choice quantum eraser experiment. Because this is usually the ultimate roadblock for any deterministic model.
Ah, yes. The delayed choice setup.
Right, because in this setup, the decision to look or not look at the particle is made after the particle has already passed through the slits.
But before it hits the back wall.
Exactly. And standard quantum mechanics argues that if you turn the detector on while the particle is mid-flight, the particle state still collapses.
Which implies retrocausality.
Yeah. It implies that your present observation somehow reached back in time and changed whether it acted like a wave or a bullet when it was physically at the slits in the past.
Which breaks a lot of fundamental logic.
It really does. So how on earth does a fluid model explain a particle seemingly changing its path behavior?
Well, it does it by rejecting retrocausality entirely. The past is absolutely not being altered.
Okay, so no time travel, thank God.
Right, no time travel. Let's apply the fluid dynamics of macroscopic transceiver coupling to Wheeler's eraser setup.
Okay. Walk me through it.
If a detector is turned on mid-flight, what physically happens in the medium based on what we just discussed?
The vacuum cleaner turns on, it creates an instant pressure drop in the fluid.
Exactly. The extended physical wave of the particle is already in transit. It has already passed through the slits.
Right, it's mid-air. Or mid-vacuum.
But because it is navigating a contiguous, incompressible superfluid, the wave instantly feels the dynamic shift in the hydrodynamic currents.
Because the shift happens in the present moment.
Yes, the entire topological landscape of the vacuum shifts the literal moment the detector activates.
Okay, I think I have an analogy for this. It's like you're floating down a river in a raft, right?
Okay, a river raft.
And you've already passed a fork in the river. You chose a path, but suddenly someone opens a massive dam downstream.
The water currents change instantly.
Exactly. Your raft is pulled in a totally new direction. You didn't travel back in time to change which fork you took.
No, you just reacted to a sudden, dramatic change in the physical fluid environment in the present moment.
That makes so much sense. The wave simply redirects its flow. It just shifts its path toward the newly opened sink.
The mysticism of time travel is completely replaced by deterministic fluid mechanics.
The vacuum is an active participant in every single quantum interaction. It's not just an empty stage.
It's the water in the river.
Yeah.
It's everything.
That is a massive relief, honestly. Trading probability magic for a physical, logical mechanism?
It definitely helps physicists sleep at night.
But, okay, if observation is just vacuum fluid dynamics, we have to talk about the other great mystery.
Quantum entanglement.
Yes. Einstein famously hated it. He called it spooky action at a distance.
He wasn't a fan of things happening without a mechanical explanation.
Right. So if we take this macroscopic transceiver coupling and we scale it down to the subatomic level, how does this framework redefine entanglement?
But if we connect this to the bigger picture, the text's explanation of entanglement provides the ultimate mechanical reality check.
Because in standard physics, quantum entanglement is treated as this non-local correlation across an empty void, right?
Right. You entangle two particles, you send them light years apart, and measuring one instantly determines the state of the other.
With no physical connection ever described, they are simply mathematically linked.
Which violates the speed of light if you think of it as a signal traveling between them through empty space.
Exactly. So what do these papers say?
Chapter 15 breaks down postulate XX, and it states unequivocally that quantum entanglement is not a probabilistic correlation.
Okay. What is it?
It is a deterministic topological connection, a literal physical tether.
A physical tether. Explain the mechanism. What is actually connecting them?
Well, when two particles are entangled at their source, their internal virtual boson BECs, their own internal superfluid cores, perfectly phase lock.
Their quantum phases become completely identical.
Exactly. And as these particles separate and move apart in space, the quantum hydrodynamic phase gradient between them doesn't just disappear.
Right, because the vacuum is a highly tensioned, contiguous superfluid.
Yes. So this phase gradient actually stretches. It stretches into a single, shared, and highly rigid quantized vortex filament within the Higgs QCD superfluid.
Hold on, so forget the old analogies of like a tightrope or a string connecting two tin cans.
It's much more dynamic than that.
Imagine two massive ships moving apart in an ocean, but they leave this highly tensioned, microscopic physical wake, like a whirlpool stretching horizontally through the water, permanently connecting them.
That's a very accurate way to visualize it. That vortex filament is an actual physical structure made out of the background of reality itself.
That is wild. And because it is a quantized vortex filament, the papers say it's topologically protected, right?
Yes, it is extremely rigid. The two particles, no matter how far apart they are, Earth and Mars, or across the galaxy, they effectively act as a single extended physical object bound by the superfluid.
So how does the instant communication work then? If particle A is measured here on Earth and particle B is on Mars?
Go back to our redefined observer effect. What happens when we measure something?
A detector absorbs energy, forcing a localized phase transition, a phase slip.
Right, on particle A's boundary.
Yeah.
And because the vortex filament connecting them is rigidly tensioned, applying a phase transition to particle A mechanically twists that filament.
You're literally torquing the whirlpool. You're twisting the fluid connection.
Exactly. And because the filament is non-dissipative within the superfluid.
Wait, non-dissipative meaning it doesn't lose energy as it travels?
Correct. This twist propagates as a non-dissipative phase shock. through the Higgs vacuum expectation value, or the VeV.
So it transmits instantly through the filament.
Yes, it hits particle B on Mars and physically snaps its boundary into the corresponding phase-locked state.
So there's no information magically traversing an empty void faster than light.
No. There is a mechanical shock wave traveling down a pre-existing physical tether in the fluid.
It's mechanical action through a hidden medium. I mean, that makes so much sense.
It brings causality back to quantum mechanics.
It really does. Which leads to the absolute wildest part of these papers.
12th prediction.
Yes, because if entanglement is a literal physical filament stretched through a superfluid vacuum, we could cut it, right?
That is the logical next step.
If it's a physical tether, can we take a pair of quantum scissors and snip it in half?
You've just hit on the exact experiment proposed in the research. They call it entanglement decoherence via vacuum disruption.
Okay, walk us through the setup. How do you physically cut an invisible whirlpool made of vacuum fluid?
Well, you start by firing two entangled photons across a laboratory.
Okay, they're traveling along their separate paths, connected by this invisible vortex filament.
Right. And then you introduce the quantum scissors.
Yeah.
An intense, highly focused attosecond laser.
An attosecond laser. We need to pause on that. We are talking about pulses of light that last a quintillionth of a second.
It's almost incomprehensibly fast.
Just to put that in perspective for you guys, an attosecond is to a single second what a single second is to the entire age of the universe.
Right. It delivers incredible concentrated intensity in an impossibly short window.
Okay, so you have these two entangled photons flying through the lab, and you fire this insane laser. Where do you aim it?
That is the crucial part of the 12th prediction, the targeting. You do not fire the laser at the photons.
Right.
You fire it transversely at a perfect right angle, straight across the empty space, strictly between their paths.
You are targeting the empty space. You're literally shooting the vacuum itself.
Yes. The goal of this intense attosecond laser is to deliver a massive localized electromagnetic shock to the superfluid vacuum.
Because the filament is in the vacuum.
Exactly. By focusing this extreme energy on a specific spatial coordinate exactly between the photons, it momentarily vaporizes the local Higgs vacuum expectation value.
It vaporizes it.
In the mathematical terms of the paper, the laser drives the local Higgs VeV to 0 in that specific spot. That's written as VDEPIO long dollar.
It melts the vacuum. I mean, for a fraction of a second, the superfluid medium that makes up space in that exact location is destroyed.
It becomes a chaotic plasma instead of a coherent fluid.
And by vaporizing the medium that the vortex filament is constructed from,
You sever the filament, you physically cut the tether.
and the result, what happens to the photons?
Immediate spontaneous entanglement decoherence. The two photons, mid-flight, will lose their entangled state entirely.
Just boom, disconnected.
Yes. And this happens without the experimenter ever measuring, touching, or interacting with either photon directly.
Which is huge, because in standard quantum mechanics, you cannot force decoherence without interacting with the particles or their environment in a way that constitutes a measurement.
Right. Classical theory says you have to touch the particles to break the entanglement.
But here, you are literally cutting the cord. If this experiment works if they can show that blasting the empty space between entangled particles destroys the entanglement, what does that do to physics?
It definitively ends the century-old debate on standard quantum probability.
It's game over for the Copenhagen interpretation.
Completely. It provides empirical proof that the vacuum is not empty, that the vortex filament exists, and most importantly, that the vacuum is an engineerable medium.
An engineerable medium. That phrase just gives me chills.
It's where this goes from theoretical physics to applied engineering.
So what does this all mean for us? If the vacuum of space is an engineerable fluid and fundamental interactions are just fluid dynamics, what happens when we scale this up from the subatomic to the macroscopic?
Now we are stepping into the practical aerospace applications of the framework.
Yes, spaceships.
Specifically, we're looking at the redefined mass paradigm. This was pioneered by Pavel Vrbovsky alongside the advanced electrogravitational solutions developed by Vrbovsky-Banić.
Okay, Vrbovsky and Banić. So to understand how we engineer a spaceship with this, we first have to completely deconstruct our classical understanding of mass and inertia, right?
We do. We have to unlearn Newton, essentially.
All right, let's assume we all remember basic high school Newtonian physics. Classical mechanics tells us that mass is just a scalar property.
Right. It's just a number representing how much stuff is in an object.
And inertia is that object's resistance to being moved or stopped.
Exactly. And importantly, classical mechanics treats translational mass, which is moving forward in a straight line, and rotational inertia spinning in place as entirely decoupled passive properties.
Meaning classically, a stationary gyroscope and a gyroscope spinning at 50,000 RPMs possess the exact same resistance to being pushed forward across a table.
Right. The spinning doesn't change how hard it is to push. That's the classical view.
But the redefined mass framework shatters this assumption.
Yes, Vrbovsky and Banić proved that physical mass is not an intrinsic passive amount of stuff.
Then what is it?
Mass is actually the integrated measure of localized electromagnetic self-field energy, and it's stabilized by its interaction with the superfluid vacuum.
Mass is just localized energy interacting with the fluid. It's not a hard, solid thing.
No, it's dynamic. And because of this, translational inertia is directly coupled to rotational spin. This introduces the concept of spin-inertia coupling.
Spin-inertia coupling. Let's break that down.
Let's examine a subatomic particle. The local spin velocity of a particle shell generates a baseline magnetic field energy.
Okay, it's spinning. It makes a magnetic field.
When you accelerate that spinning body linearly, when you try to push it forward, the local total velocity against the vacuum fluid becomes asymmetric.
Okay, let me visualize this for the audience. Imagine pushing a sphere that is spinning clockwise through a pool of water.
Good analogy.
The side of the sphere spinning into the direction you're pushing it has a higher total velocity relative to the water.
Right, the spin and the push add together on that side.
And the side spinning away from the direction of forward motion has a lower relative velocity. So the front is pushing harder against the fluid than the back.
Precisely. That difference in relative velocity creates a differential in the magnetic fields generated by the spinning shell.
And what does that differential do?
This inward magnetic pressure squeezes the particle's boundary asymmetrically. It actually shifts the local center of mass.
Whoa!
Because of this dynamic fluid interaction, mass can no longer be treated as a scalar number. Mass transforms into a highly dynamic tensor.
A tensor. Okay, meaning it's a property that depends on direction.
Yes.
So your mass, like your physical resistance to acceleration, could literally be different depending on which direction you were trying to move. It's directional mass.
It is directional mass, and this leads us to the most critical mechanism for advanced aerospace engineering, the mass defect.
The mass defect. Okay, how does that work?
When physical systems of charges form a bound state, like atoms forming a solid object, their overlapping electrostatic and magnetic fields undergo spatial interference.
How exactly do overlapping magnetic fields destructively interfere?
Well, in a stable bound state, the quantum alignment of their internal spins and current loops can be positioned such that their self-generated magnetic fields actually cancel each other out in certain regions.
Like noise-canceling headphones, but for magnetic fields.
Exactly like that. This destructive superposition causes a physical loss of field energy.
And that loss is the mass defect.
Yes. And because we established that mass is just a measure of field energy, this destructive interference physically reduces the system's total inertial mass.
Let me make sure I've got this. If you can align the spinning magnetic fields of the structures in an object so that they destructively interfere with each other, you literally delete some of their mass.
You reduce its inertial resistance. Yes.
You make the object easier to accelerate in a specific direction. That is incredible.
Now, apply this to the biological limits of human spaceflight and aviation.
Right. Think about modern fighter pilots. The human body is incredibly fragile when subjected to sudden changes in speed or direction.
We aren't built for high G-forces.
No. When a pilot pulls an extreme maneuver in, like an F-22, their body wants to keep traveling in the original direction. The blood pools in their legs, their tissues strain.
And if the force is extreme enough, they suffer GLOC, G-force-induced loss of consciousness.
They black out, or worse, their internal organs sustain massive damage.
And this happens because the high virtual mass of their bodily tissues actively resists the sudden change in direction.
The inertia of their own atomic structure is fighting the directional change of the aircraft.
Exactly. And because we classically couldn't change the laws of physics, we've historically just built better flight suits.
Right, suits that just squeeze the pilot's legs to keep blood in the brain. It's a biological band-aid.
But this fluid framework offers a physics solution. Active G-force mitigation.
Active G-force mitigation, how do we do it?
The aerospace application described in the text involves equipping the aircraft's cockpit structural frame with high-speed, counter-rotating electromagnetic gyroscopic rings.
Massive, highly charged magnetic gyroscopes spinning at incredible speeds around the pilot seat, like a spherical cage of spinning rings.
Yes, and the engineering key here is dynamic alignment. We want to exploit the parallel mass-defect tensor coordinates we just discussed.
Okay.
The flight system must dynamically adjust the spin axis of these rings. Let's call the spin axis omega, or omega.
Okay, omega's the spin axis.
So we adjust omega so that they point exactly parallel to the vehicle's acceleration vector, which we'll call a dollar.
So omega is parallel to omega parallel a dollar,
Correct.
meaning if the jet yanks hard to the left, the gyroscopes instantly tilt so their spin axis points directly left, perfectly aligned with the new vector of acceleration.
Exactly. By aligning the spin axis parallel to the acceleration vector, engineers can maximize the negative mass interference defect.
Wait, they are intentionally overlapping the electromagnetic fields of the spinning cockpit rings with the atomic structure of the pilot's own body.
Yes, with the pilot's own nucleons.
You are causing destructive interference between the ship and the pilot's physical body.
Yes. This parallel alignment physically lowers the effective virtual mass of the entire cockpit system, including the biological tissues of the pilot.
Specifically along the direction of the turn.
Exactly. The pilot's tissues literally have less inertial resistance to the turn because their mass tensor has been dynamically engineered in real time.
That is absolutely mind-blowing. And the papers calculate that this active shielding, this gyroscopic mass defect exploit, can mitigate the g-forces felt by the pilot by up to 30%.
30% is a massive reduction in aerospace engineering.
It's staggering. A pilot pulling a lethal 10G maneuver would only experience the physical, biological toll of a 7G turn.
Which is highly survivable.
You are pushing the mechanical limits of the aircraft, far beyond the current biological limits of the human inside it. It's essentially an inertial dampener straight out of science fiction.
The ship turns, and the physics of your own body are hacked so you don't feel the full force.
Okay, so we survived the extreme g-forces. Our pilot is maneuvering like a UFO.
Right.
But that brings us to the next massive hurdle of space travel. How are we powering this ship?
Propulsion.
Right, because Newton's third law says every action has an equal and opposite reaction. If we're in the vacuum of space, we supposedly have nothing to push against.
That's the classical problem.
So to move forward, we have to throw something out the back. We have to burn rocket fuel.
Which leads to the tyranny of the rocket equation.
Explain that for the listeners.
Well, to carry a heavy payload into space, you need a massive amount of fuel. But fuel has mass.
Right.
So to lift that fuel, you need more fuel to lift the original fuel. It is a brutal exponential curve that makes continuous long-range interstellar travel practically impossible with chemical rockets.
But everything we've unpacked today hinges on one specific reality.
The vacuum of space is not empty.
Yes, it's a fluid, which leads to the final and perhaps most profound application in the Banić and Vrbovsky papers.
Reactionless, propellantless propulsion.
Propellantless propulsion. We don't need fuel.
We do not need to throw mass out the back of the ship because we actually are pushing against something. We just couldn't see it before.
We are pushing directly against the polarized virtual electron-positron pairs of the superfluid vacuum itself.
Exactly. We are gripping the fluid.
Here's where it gets really interesting. We are swimming in a frictionless ocean, and this framework gives us the blueprints for a propeller. So how does the engine actually grip the vacuum fluid?
The mechanism relies on asymmetric pointing resonators.
Okay, pointing resonators.
A pointing vector, mathematically, represents the directional energy flux of an electromagnetic field.
It's the momentum carried by light and magnetic fields.
Right. It is the cross product of the electric field, AB8A, and the magnetic field, Baller. The volume integral of $1 times BAD.
The volume integral of E cross B. Okay, I'm with you.
So by using highly engineered asymmetric electromagnetic momentum resonators, a ship can generate a severe, highly directional pointing vector momentum flux.
Meaning it creates a massive imbalance of electromagnetic momentum pointing in one specific direction inside the drive.
Yes, building up a massive wave of electromagnetic pressure inside the engine chamber.
And because momentum must be globally conserved in the universe?
This severe internal momentum flux imbalance has to be offset. The system physically transfers this momentum to the local vacuum.
It electromagnetically grips the virtual pairs of the Higgs QCD superfluid?
Yes, and this generates a real physical thrust in the opposite direction.
A propellantless drive. You feed it electrical power, maybe from a nuclear reactor. It creates an asymmetric electromagnetic momentum field. It pushes against the physical fabric of the vacuum itself, and the ship moves forward.
With no exhaust, no massive explosive fuel tank.
Just pure electrogravitational traction against the background of reality.
The implications for humanity are difficult to overstate here.
I mean, by eliminating the need to carry massive amounts of propellant mass, these pointing thrusters provide the first theoretically viable pathway for continuous long-range interstellar travel.
You could accelerate continuously for months or years, reaching relativistic speeds.
All by pushing against the very vacuum that classical physics told us was completely empty. It's beautiful.
It's a complete paradigm shift in how we interact with the universe.
We started this deep dive talking about the esoteric chalkboard mysteries of quantum particles, and we ended up with the literal blueprint for a warp drive.
It all scales up.
We've traversed the hidden architecture of reality today. We learned that the observer effect isn't magic.
No, it's a physical detector acting as a thermodynamic vacuum cleaner.
Right. Drinking energy from a superfluid and paving a hydrodynamic path for particles.
And we learned that quantum entanglement is in spooky action at a distance.
It's a rigid physical tether, a quantized vortex filament that you can literally vaporize and sever with an attosecond laser.
The 12th prediction.
And finally, we learned that mass is not just a stubborn scalar number.
It is a malleable directional tensor.
A tensor that we can hack using counter-rotating gyroscopes to build G-force shields and interstellar drives.
It is a profound reminder that the universe is not a collection of abstract, passive laws. It is a dynamic, physical, and ultimately interactive machine.
It absolutely is. And, before we go, I want to leave you guys with a final, unmentioned speculation based on the mechanics we've covered today.
Oh, I'm curious.
We talked about applying this spin-inertia coupling to massive fighter jets and spacecraft.
Yes, the active G-force mitigation.
We talked about equipping a cockpit with electromagnetic gyroscopes to reduce the pilot's mass defect. But if the vacuum is a fluid and mass is an engineerable tensor, what happens when this technology inevitably shrinks?
Oh, scaling it down.
Yeah. Imagine a future where this scales down to personal tech. Imagine a wearable inertia suit.
Packed with microscopic gyroscopes.
Exactly. Millions of microscopic, counter-rotating electromagnetic gyroscopes woven into a suit. A suit that aligns with your movement to alter your own localized mass defect.
That is a fascinating thought experiment.
Right. Could dialing down your own physical mass by 30% on demand allow you to sprint at incredible speeds?
Your inertial resistance would plummet.
Could you jump over physical obstacles as if you were walking on the moon simply by telling your suit to destructively interfere with your own atomic inertia?
Once you realize the rules of inertia are written in a fluid medium, the only limit is how precisely we can engineer the currents.
The universe is fluid. Perhaps our physical limits are too. I absolutely love that. Thank you so much for joining us on this deep dive.
Thanks for having me. It was a great conversation.
Keep questioning the reality around you, keep looking closer, and we'll see you next time.